Okay. Trig 1.1 examples here. Let's see what we have. Let's go from the beginning. So, Trig 1.1 examples. And this is on those basic equations. And here is our first example. And this example was those crazy ones where I said you need to find common denominators. And what I realize here is I have a t plus 2 on everything except for this one right here. So I'm going to need to put a t plus 2 on the bottom and the top of both of these. And this has a 3, but this doesn't. Or this. So I'm going to need to multiply this by a 3 on both the top and the bottom. So I got to see if I can factor. The word I need to factor. Find common denominators. So this I need a 3 on both the top and the bottom. I need a 3 on both the top and the bottom on this side. Now I have a 3 on the bottom everywhere. Next up is I need a t plus 2 on the bottom and the top everywhere. Or not the top 2, but if I multiply on the bottom, I need 1 on the top. So now I have on the bottom a 3 times t plus 2, 3 times t plus 2, 3 times t plus 2. All the bottoms are the same. I multiply the top of this one by 3, that's why this is 3 times t squared plus 1. I had to multiply this one by t plus 2, which is why it's t times t plus 2. And 5 times 3, I just jumped the gun and wrote it down as 15 now. Okay, so now don't worry about the bottoms. Let's worry about the tops. So I'm going to FOIL that top through. 3 times t squared is 3t squared. 3 times 1 is 3. T times t is t squared. T times that 2 is 2t, and I still have 15. So now I need to put everything together and find common denominators. I am going to put my like terms together. So I'm moving this over because I like to make my t squareds positive. So 3 minus a t, it gives me a 2t squared. I still have a 3 on this side. Still have a 2t and still have a positive 15. I'm going to move this 2t over because, like I said, I want to keep this positive in the front. So there are no t's over here, so that's why it's just a negative 2t. Still have that plus 3. Still have that plus 15. And because this is a quadratic, I'm going to keep moving everything over. So I'm going to subtract the 15, so I end up with 2t squared minus 2t minus 12 equals 0. Okay, got a quadratic equation to solve. So to solve that quadratic, I realize, hey, I can take out a 2 from everything. So I take a 2 out because every single number there is divisible by 2. So I took that out. So now I got to see, can I factor this? Okay, so let's find out if we can factor this or not. And for some reason, I guess it was lagging there, but the correct answer is yes, we can, because negative 3 times 2 is negative 6. So what multiplies to give you negative 6? That works. That also adds to give you negative 1. Negative 3 and positive 2 work. So I set each of those equal to 0. T minus 3 equal to 0. T plus 2 equal to 0. And I solve them. So I add 3 on both sides. I get t equals 3. Subtract 2 on both sides. I get t equals negative 2. Now remember, those are possible answers. It doesn't mean they work. So we need to check the original to see if it works. So when I plug in a 3, 3 plus 2 is 5. That works in the bottom. 3 plus 2 is 5. That one works in the bottom. So that's okay. The bottoms all work, because remember, the bottom is my big concern. You do not want a 0 in the denominator. That's the big concern here. That's what you're looking for. Take this negative 2 and plug it in. Negative 2 plus 2. Whoa. I get a 0 on the bottom. That means I have an undefined number, and you can't have an undefined number. So that means negative 2 doesn't work because I end up getting 0 in the denominator. And I cannot have 0 in the denominator. So negative 2 doesn't work. The only answer to this problem is 3. Alright, with this one, step number 1 is to factor. Alright, well, can I factor any of those bottoms? Right here I can, right? Because what squared can give you 1? This is a difference of squares problem right here. So this is actually x plus 1 and x minus 1 on the bottom right here. Okay, so if that's actually x plus 1 and x minus 1 on the bottom, and look what I have here, an x minus 1 and x plus 1, so it is becoming a little clearer on what I can do. I have an x minus 1 in this one. I even have an x minus 1 now in this one, but I don't here. So I'm going to need to multiply the top and the bottom by an x minus 1 here. I have an x plus 1 in this one. I have an x plus 1 in this one, but I don't have an x plus 1 in the far one, so I'm going to have to multiply both the top and the bottom of this one by x plus 1. And if you notice, I also right here decided to factor the top of that one. So, this is what I have with everything factored. We realized what I need to multiply everything by to find common denominators, because I have a x plus 1 and x plus 1, but not here. So x plus 1 is both the top and the bottom. I have an x minus 1 and x minus 1, but I don't have an x minus 1 there, so I multiply the top and the bottoms there by x minus 1. And here's what it all looks like. Every single bottom now is x plus 1, x minus 1, because I multiplied everything. The top is fine here. This is x minus 1 and x minus 1 now. This is x plus 1 and x plus 1 now. But remember, the bottom doesn't concern me now until the end. Alright, let's worry about just the top to solve. So here's my top. A whole bunch of foiling is what I'm going to have to do to solve this problem. X times x is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. Over here, x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. And that equals 2 times 1 is 2. 2 times x is 2x. Whew. Whole bunch of stuff there. Okay, so what to do, what to do. Let's combine like terms. An x squared and x squared is a 2x squared. An x and a negative x, they'll cancel out. I have another x and a negative x. They'll cancel out. So all I have left over on this side is a 2, because a 1 plus 1 is 2. And I have a 2 plus 2x left over on that side. Let's start combining like terms. I realize if I subtract a 2 on both sides, they're gone. So I'm actually left with 2x squared equals 2x. And this is a quadratic, right? It's squared. So because it's quadratic, why don't I move a 2x over? And I end up getting this. What do they have in common for me to pull out? They both have a 2, right? They both have a 2, and they both have an x. So I pulled out a 2x. When I do that, here are my two things to set up to solve. I set 2x equal to 0 and x minus 2 equal to 0. So I divide both sides by 2 and I get 0 as an answer. And I add 2 to both sides, I get x equals 2 as an answer. Okay, so I have 0 and I have 2. So I have to see, can both those work? If I plug a 0 in the bottom, that works. If I plug a 2 in on the bottom, do I get 0 anywhere? Nope. So because I don't get that anywhere on the bottom, it works. So now we look at the original problem, and it looks like when you plug in 0 and 2, plug them in, and I don't get it anywhere, so they both work. So those are the right answers for both problems. Okay, so let's see how the next problem looks. We got another crazier one. This will probably take a little while, so I don't want to rush through the problem to give you an answer. So when we come back here, I will finish up on the examples.